So good afternoon. I'll try to be prompt in this presentation. So we're going to be talking about practical use cases of having implemented smart grid projects. And we talked about digitalization in the past. It's a real pleasure to bring those cases to you. Hopefully they'll be very interesting. So the first thing I'm going to be talking about is our former CEO, Thierry Breton, who unfortunately left us last year to join the European Union. You know, he's the first commissioner now over there. But still, last December, we won the EcoVadis Sustainability Index from the Dow Jones, which means that we are not presenting what I'm talking about yet. So go ahead. All right, so for us, yeah, for us, slides is not important, yeah? But what's important indeed is the decarbonization. And we talked about energy transition. Let me give you some ideas of what energy transition means for us. Indeed, today, the digital industry uses about 5% of the world energy, 5%. 2050, we'll be using 25%. We'll be one of the first consumer of energy, the digital industry. And the problem is, today, about 20% of the energy comes from renewables. By 2050, it'll be 80%. Our computers don't like this intermittent sources. So how are we going to cope with the more stable? And I'll give you examples of how can we reduce this intermittence of the renewable generation. So for us, decarbonization is important, not just for us, because we will have to become decarbonized as an industry, but how can we help our customers to decarbonize is also a very, very important key. So what we would like to do in our strategy moving forward is to build the digital age for the energy of tomorrow. I'll be quick in giving you those facts that I'm sure you all know, and I will skip what ATOS does in the industry. We are part of all the value chain from power generation, transmission, distribution, and the retail sector, and oil and gas. The first electrical system, you know, renewables' big problem is the low ability to forecast its generation due to the fact that we're adding not only temperature, but we're adding nebulosity, that means the darkness. We're adding as well the wind, which is very difficult to predict. I can give you an example in France. 1 degree plus minus in the grid, in the weather in the French territory means plus or minus 1,000 megawatts. 1 degree variation, 1,000 megawatts. That means one nuclear power unit, less or more. And the problem is weather forecasts today, and we work with Météo France. We developed a very good partnership with them to use our computers, our modeling, to increase this ability to generate better weather. But not only we do that, we also work with the European Space Agency. You know, they have a fleet of satellites, so-called the Copernicus satellite fleet, and ATOS runs the data platform for using all this data coming from all these satellites and maybe having real-time observation to increase this predictions based on cloud movements and so on and so forth. And let me give you as well a use case here we did for Enedis. You know that Enedis, because of the move, and we haven't touched too much on this so far, so-called distribution system operator, which is the future, the move from network operator to a system operator. And based on that, that means Enedis needs to balance the network. And to balance the network, they need to purchase energy. I can give you some figures. I hope Enedis will forgive me if it's no, but they are public. They are part of the public TURP, as we say, the tariff. 25% of the cost of Enedis is to buy energy to RTE to balance the grid. Okay, and the amount is quite significant. And the reason is because of the intermittence comes at the last hour, at the last minute, at the last second. So they need to purchase this power on the real-time market, which is very expensive. So any ability to anticipate these imbalances with data modeling will reduce this inability. So this is a practical example which I think can be applicable as well for the Indian market. Another one, we're going to be talking later about digital asset performance and the digital twin. Here I'm just going to be talking about something we've done for the Indian market together with an Indian partner, so-called Renom. And together with them, they are a large OEM, and you have here a link to the YouTube where you will see this digital twin platform we have done here is to increase the asset availability coming from the wind farm. Because you know, wind farms reliability tends to be at percentages that are let's say can be improved, and any possibility to increase this prediction of the asset utilization is very important. Okay, third use case which I would like to talk about is smart city. We touched on this earlier on with the smart grids, microgrids. And here what I would just like to talk about is this European funded project that we have, we are the system integrator. We got 2.3 million euros for the city of Grenoble and Amsterdam to build a data portal, gathering all the data coming from the various sources, including the smart meter, and the idea and the various ecosystems. And it's the idea is to build a multi-energy portal where you will have, for consumers, but also for the city, the ability to improve their energy consumption and to empower the citizens in the loop. We have done all this where the users can connect to the platforms, but also the city to do better energy management for the city and the public buildings as well of the city. Okay. And the last use case I'd like just to bring is this solutions we have developed for doing solar farm inspections using drones and artificial intelligence. And here the idea is to fly over the assets with the drones and automatically with artificial intelligence detecting faults with machine learning and even deep learning. This technology is also applicable. We've done a use case for Austrian power grid, where we're going to detect corrosion and we're going to levelize and categorize the corrosion levels by using the same technology that Apple uses to recognize faces with this machine learning and deep learning. That's it. I'd like to maybe hand over to my next colleagues, but looking forward for the discussions. Thank you.
Thank you so much, Paul. Really appreciate it.